With me today, Cecilia Ren and Ocean Valencia from the University Library in Sorbonne. I will present the first part and then they will present parts 2 and 3. Please note that we are recording this session today and the video will be put online on the 4EU Plus website along with the slides from today. So this is what we have planned for today. We're going to talk about data management plans, and we chose the subtitle "One Tool with Many Applications." We hope that you'll find it useful for your own research project in hopefully many different ways. A data management plan can be used for a lot of good purposes. First of all, I will give an introduction to research data management in general, because that's really the background for why we are talking about data management plans. Then I will try to motivate you why good research data management is important, and then how you start to plan your research data management in a good way. Cecile will take over then for the second part and show you how to actually write your own data management plan, and she will show you examples from templates, typical questions in a data management plan, and example answers. And finally, Ocean will focus on the open science aspects related to data management, and that is mainly deciding what to share and how. So what types of your data can you make openly available to other people, and what is the best way to do that? I should also mention we will take all questions in the end. If you have questions along the way, please put them in the chat, and then we will collect them in the end. We should have plenty of time for answering questions and for discussions in the end. I was also asked to tell you to use your full name as your username, so we can keep track of who has attended. Well, let's get started with an introduction to research data management. What is it? What do we mean by that? Some of you may have seen this illustration before, or a very similar one. This is a model we call the data lifecycle to illustrate aspects of data management around a research project. And I would say a research project in general has 3 phases. There's a preparation phase. That's when you design your research question, come up with good ideas, find your collaborators, write a grant proposal and secure funding. Then there's an active phase of research. That's, I would say, the actual research. That's when you go into the lab, go out into the field, or simply sit in front of your computer and do the analysis, whatever way it is that you're doing research. And there's a dissemination phase, which is about communicating, publishing your results, writing articles, your PhD thesis, maybe going to conferences, and so on and so forth. In each phase of a research project, there are aspects of data management to consider. Of course, this is not a linear process. You often go back and forth between the active phase of research and the preparation phase, maybe when new ideas, when you have new ideas or new collaborators come into the project. But when you start preparing a project, planning data management is a very important aspect. That's to consider the whole framework. What types of research data are you actually working with? What could challenges be? Do you need some agreements in place regarding data management, for example? In the active phase of research, you start out usually with collecting or creating some kind of material or data. You can do that yourself, or maybe you get the data from a collaborator, from another source. Process and analyze your research data often in multiple ways, many different steps, back and forth. Storage is a main concern during the active phase of research. What is appropriate storage for the type of research data that you have? How do you secure it? What is your backup strategy? Do you need access management to your material and data? During dissemination of your research, you will most likely also share some of your research data, for example, with your colleagues and collaborators, but maybe also broader with your community, with external people, with publishers. You might actually publish original research data besides your articles. Towards the end, preservation is a big concern. Many of you will maybe leave the institution, find a new job when your project ends, or go to another research group. So it's important to think about what kind of your research data to preserve beyond the scope of the project, with the hope or the anticipation that at least some of your research data can be reused. For example, for a new research project, can be reused by yourself in the future, maybe also to write more articles, or by someone else, by your research group for new findings, articles, or by the next PhD student joining. And for example, to avoid having to do the same things all over again. So that can save a lot of time and money eventually in research. This is the very broad overview of what research data management entails, but how to do that in practice really depends on your discipline, how you work, and what kind of research data you are working with. I just want to show you some examples to really cover the whole spread. Some of you might work with animals, live animals in the laboratory, and there are often ethical questions to consider. You might have to get specific approvals for working with animals. You have to follow very specific protocols and so on and so forth. Others of you maybe work with human participants, which leads to whole different challenges. First of all, how do you approach the human participants? How can you make them trust you and the results? And there are matters of privacy and confidentiality to consider. Some participants might be very reluctant giving you information unless they know you really handle those in a very secure way. Maybe some of you work with data that have been published previously, published collections, maybe historical data. The question there could be how to get access to those data. There might be matters of copyright to consider, so someone else who actually owns the data and determines what you're allowed to do with them or what not. We're often talking about research data in digital form, but it also includes physical materials, all kinds of samples, biological or geological samples, for example. Here, big challenges usually relate to storage, transportation, and preservation. Can be very, very large amounts, can be very heavy, they can be fragile. So how to take really good care of those. Some researchers work with theoretical models entirely. It's not a big problem in itself, but maybe you want to test the models through simulation, and then you need good data sets to run your simulations on. Could be real data, or it could be simulated data. So how to design that, how to get access to good data sets to test your models. Textual data is another example for a typical kind of research data, I would say. Very common, for example, in the humanities, and more recently, there's an area called digital humanities, which have gained a lot of attention. which is about using data science method on textual data, and that requires that you have text in digital form in a very good quality, in a well-structured form, so you can, for example, do text and data mining on them or natural language processing. Finally, it also depends on how you actually obtain your research data. For example, through observation, that's when you go out in the field, for example, and take notes on what you see. And of course, those data, they are always collected at a given place at a certain time. That also means they are not reproducible. You cannot go out the next day and expect to get the same results, maybe similar ones, but definitely not the same. And those data are also often a mixture of qualitative and quantitative data, which can be very tricky to structure, to document. If you do measurements in the lab, for example, you might follow certain procedures, best practices, keep a lab notebook for documentation in a very structured way, to note down all the conditions, all the parameters, all the details of your experiments, so that hopefully the results can be reproduced, or at least the experiment can be replicated and you can get similar results. If you work with statistics, you have to concern with things like statistical errors, outliers. What are outliers really? What is the definition? And really make sure that the method that you're using is valid and transparent. So these are just a few examples, and I'm sure there are many, many more different ways of working with research data, different types of research data that have consequences for your data management. So why is good research data management important? Why is there so much focus on that? First of all, if you plan your research data management properly, you reduce the risk of running into problems later on. Also helps you to align expectations with the people that you're working together with, your collaborators and your supervisor, for example. Documentation is very, very important for finding and understanding data in the future. And this is an example that I guess those of you working in a lab are familiar with, how to correctly label chemicals. So if you have a bottle of something in the lab, a good way of documenting would be to add the date, the expiry date, a detailed description of what the contents are, the name or the initials of the owner, and a reference to a page in your lab notebook, for example. But in reality, of course, hardly anyone is doing that. So usually it's just something hastily scribbled that maybe makes sense at that exact moment, but already a few days later, not even yourself could probably remember what that was specifically, let alone anyone else who is in the lab. And of course, that can mean it's a waste of time and effort, but in some cases it could even be dangerous if you don't know what's inside the bottle. Appropriate storage and security measures help to prevent data loss or leaks. And here's the horror story of the PhD student who lost their backpack, or maybe it was stolen, we don't know. That person writes, there's an external hard drive in the backpack, very important as it contains 5 years of research data, which are crucial for the PhD thesis. Probably the worst thing that can happen to a PhD student, but it's also something that could easily be avoided by having a good backup strategy. Never keep everything in one place on your own laptop or an external hard drive. Always make sure that there are multiple copies and maintain them. Publication of data makes your research more visible. So you increase your research outputs by not only publishing articles, but also research data and code maybe, so other people can see what you're doing, use your results. That might also lead to more collaboration, more impact in general. And finally, preservation of data would ensure that you can provide evidence for your published results if necessary, and that's actually a requirement that you have data underlying your articles, for example, available to demonstrate that what you have written in your article is valid. You see, unfortunately, quite a few papers that have to get retracted because the underlying data is not available anymore. You see an example here, a retraction notice, and in that case, it was the authors themselves who retracted the paper because they found an error in their analysis. But they couldn't correct the error because they didn't have the original data available anymore. Here it says, due to the loss of the raw data, the paper had to get retracted. And I would say that's a really bad thing to happen in a researcher's career to have a paper retracted. So this is definitely something you want to avoid. So these were all, I would say, benefits for yourself as a researcher, but there's also a broader perspective to that. For example, there are some research communities that already have traditions for sharing data, code, and protocols, where it is simply common to do that. Funders might require you to make your results publicly available because they say, well, they provide the money, so they want to have what they call a return of invest. So they want you to make as much output openly available as possible. More and more publishers are asking you to provide data to peer reviewers and eventually also to the readers when you submit a manuscript to them, and they might have very specific requirements. Institutions are implementing policies regarding research data management, for example, to ensure information security. So it's important for them to know which data are stored where, and how to ensure that this is in a safe and efficient way. And finally, policymakers want to promote data reuse. The amounts of data are growing more and more. And there's more interest in actually reusing data and really unlocking the potential of research data. So there are more and more policies and guidelines coming out. For example, if we go to the very, very top level, the European Parliament, they have updated the directive on public sector information, the so-called PSI directive, to explicitly include research data. So it says actually research data from European research institutions have to be open by default. And this is currently being implemented by all the member states. And then there's the European Code of Conduct for Research Integrity, which I hope that you all have seen, which also outlines some general principles for good research data management to ensure, for example, transparency, trustworthiness, and integrity in general. Here's an example from a funder, and this is the biggest funder in Europe, the European Commission. In the Horizon 2020 framework program, which was the previous one, they introduced the so-called Open Research Data Pilot, which requires participants to provide open access to research data generated in the project, specifically data underlying publications, but also what they call other research data of their choice. And all projects that get funded in the Horizon 2020 framework program have to write and submit a data management plan where they outline their data management strategy and what they will make openly available and whatnot. Of course, not all types of data can be made openly available, and Lucian will talk more about that later. So the slogan has been as open as possible, as closed as necessary. So you cannot, if you cannot share all your data, you have to explain why. You have to write that in the data management plan. Horizon 2020 just ended as framework program, and the new framework program has started, Horizon Europe. The requirements are very, very similar, a little bit extended, but you still have to write a data management plan, and you still have to outline how to provide open access to research data, and also describe any exceptions. Then there are a number of other funders, national funders, some examples here: the National Science Center from Poland, the Technology Agency of the Czech Republic, Innovation Fund Denmark, or the French National Research Funder. They also have policies regarding research data management and open access to research data. Then some universities have already implemented policies for research data management or are currently doing so. Sorbonne, Milan, and Heidelberg have that already. University of Copenhagen is just about to publish a new policy, basically as we speak. So please make yourself familiar with any requirements from your own research institution or your funding agency, if that applies to you, what the rules are for research data management, or at least recommendations. So this was, so to say, the framework, how to get started with planning research data management. So the recommendation, or in some cases also the requirement, would be to prepare a data management plan at project start. Ceci will show you more in the second part. Start out with describing the types of research data that you're working with, by providing a definition and a classification, by identifying potential risks and challenges that follow your types of research data. And it's very important to clearly assign roles and responsibilities if you're working in collaboration, who is doing what, who is responsible for what. And that will then help you to align expectations, for example, with your supervisor and collaborators. There are a number of different templates available for data management plans, for example, from funding agencies. You see the Horizon Europe template here, from universities or from other research organizations, like, for example, Science Europe or the Digital Curation Center in Great Britain. Those templates, they contain a number of questions related to research data management that will guide you through the whole process. So what could it look like? And I want to demonstrate that in this picture here. First of all, it's important to define the data types that you're working with, and what are special challenges with those data types. For example, if you have big data, if you have petabytes of data, you need special infrastructure for storage and data exchange. If you have personal data or otherwise confidential, sensitive data, you have to take very special care of that. We're talking about genetic data, biological material, health data, and so on and so forth. They are very sensitive, so you really have to think about information, IT security, about storage and backup. There might be costs related to storing and retaining those data. Then think about who you're working with, who are your collaborators at your own university, at other universities, public partners, private partners, collaborators in other countries or remote places, because that might influence workflows for research data management, getting access to the data, and the distribution of rights and responsibilities. For example, if you have a private company collaborating with you, one example here is Novo Nordisk, a Danish pharmaceutical company. They collaborate a lot with research, but there might be information that they want to keep confidential, don't want you to disseminate. So there might even be a contract set up. Think about what are the requirements that apply to your type of research data. For example, the GDPR, General Data Protection Rule, for personal data. There might be ethical considerations. There might be requirements from your funding agency, as I showed you before, or from the journal that you want to publish in. And this influences, for example, what you retain after project and how you will retain. Some types of research data have to be destroyed or deleted at project end, for example. What are practices for documentation, and so on and so forth. In particular, when you work with, for example, animals or genetically modified organisms, there are ethical considerations. And finally, who is the target group of your research? Definitely researchers in your own field, but maybe also in other fields. Interdisciplinarity might be important. Could be special interest groups, policymakers, industry, or the citizens in general. For example, now, of course, if you work with any research related to the coronavirus, you have to make your results immediately available, openly. If you work with biodiversity, you're also expected to make your findings available, for example, through the Global Biodiversity Information Facility, which collects all the information. Or if you're working with the genetic data, there's pretty much standards to put your data in the gene bank. So these are 4 aspects which kind of define the framework for your research data management. And I would say it's a good start to identify your data types, your collaborators, the requirements, and target groups to really design your data management strategy. So how to get started, how to do that in practice. Draft the first version of your data management plan to outline your strategy. You probably don't know all the details in the beginning, so you might update the plan along the way. Really use the data management plan as guidelines in your project. That also means discuss and review the plan regularly with your supervisor, with your collaborator, and keep the data management plan along with other project documentation. It's really important that your data management plan is a living document that you use actively. And this will help you to achieve better security, to improve the quality of your research data, to work in a time and cost-efficient way, and also to finally improve your impact. And with that, I will hand over to Cécile, who will go through some example templates.
We will look now what data management plan is in the detail. So a data management plan is a document with 8 parts, what are the same in all the types of data management plans, and we're going to look at it in the detail. So for the first part, with data collection and description, in this part of your DMP, you have to describe what data will be produced or used during the project. For example, the type of data, the format, or the volume of your data. You can also explain how it will be produced or transformed. For the second part, documentation, it's a key part of your DMP. If your data is not documented, it can be reused correctly. This part will be explain which metadata we used. We will define the metadata later and how they will be generated. In this part, you mention the data identifier. For the part storage and backup, it's not very complicated to complete. However, it's very important because it forces to anticipate the risks of data loss, as Falco explained it in the first part. In this part about storage and backup, you have to ask you how, where, by whom will the data be stored, backed up, and secured. Then there is a part about lawfulness and ethics. This part will be about data ownership and about the rights to reuse existing data. It allows to anticipate the question related to the sharing of data, which will be possible or not according to the type of data. If personal data is collected, the procedure for anonymizing the data can be described here. In the part data access and sharing, this part explains who can access to the data, where and how it will be published, with what license. We will see the license later. We have then another part, responsibilities and costs. This part will specify who in the team is responsible for managing the data and who writes the GMP. When working in a team, it allows to correctly assign the roles of each person. The data management budget should also be detailed here. How is data management and sharing founded, especially over the long term? And the last part is about data long-term preservation. It's about what is the long-term archiving and preservation plan. So for the first part, in the data description section, you will explain what data you collect or reuse. The objectives are to identify and list the types of data sets that will be collected or generated in the project, to specify the purpose of the studies, the geographic origin of your data, and the time period. And then you need to explain the purpose of collecting these different types of data. In practice, you will need to write down as you go along the conditions of that data collection, the software used to produce and process them. If possible, use open files formats or the formats used in your field. Specify which ones in the GMP. And finally, in this part, you will need to organize and name the files in a coherent and understandable way, and then explain it in the GMP. We will see now an example for the description and collection of data. So in this, here is an example of a data management plan already published by its author. You will have the link if you wish to read it. In the description part, you can see that each type of file is described and the formats used are specified. This description focuses on data typologies and file formats. Another example is about data organization. The files are organized as follows. Sorry. A first part on project management with administrative documents, meeting notes, data management plans. So a second part contains the materials and methods with protocols and codes. And a third part is with the data, raw data and process data. In the fourth part of this example, you have the analysis with the code of the libraries needed for the analysis. In the fifth part, the figures, and in the sixth part, it's about the dissemination of the results with the reports, the manuscripts of paper. So the parent folder deposited in Zenodo includes all the architecture of these files, and you have, of course, a README file to explain how use this tree structure that is very interesting to adapt and reuse if you want. Then another example about naming conventions. For name your file, you need to identify the topics on your file, find abbreviations to each one to have short names for your files. You need to versioning the files, and you, if it's possible, keep the name as simple as possible. And then if you can write down your naming convention in a document to explain it to others. Think about how your search for your files to give them relevant names. Two examples, you can name it with the name of the project, the topic, the date, and the version, or another solution is to begin with the date, then the project, then an identifier and the version. So a tip, don't never name your files like that. So for the second part, documentation and data quality, you have to, the principal objective is to give all the information to someone who did not participate in the project, so that he can reuse your data. And in practice, you will need to describe your data with metadata. Metadata is like the information on the label of a tin can. Sorry, if you don't have a label on the tin can, you don't know what's inside. It's the same for the data. Then you will need to assign keywords, or better yet, use specific vocabularies to your field. In health studies, for example, a well-known and widely used vocabulary is mesh. And then you need to add a README file to your data set. So some examples too. First, if you deposit your data on data repository, you will have metadata fields to fill in, as well as keywords to add. So here is an example of metadata fields to fill in a repository. And an example for the keywords. So metadata issue is very simple for you if you deposit the data on a repository. And then you can also attach a README file to your deposit. For the part about storage and backup, the objective is to secure your data, especially if they are sensitive, and to prevent the risk of data loss. In practice, we recommend you keep several copies of your data on different storage locations. You can use a 3-to-1 backup rule. It's 3 copies on 2 different medias with at least one remote copy in a cloud. You need to favor robust storage systems with automatic backups, such as those provided by the IT services of your university. You need to manage access to data with and secure access for partners with verification of the access at the end of the project or in case of departure of a person. And then you need to encrypt your data if it's sensitive. And of course, use a secure cloud for remote access. Two examples about storage and backup. In the first one, the author mentioned that they host some data on a platform subject to their organization's IT security policy. And then they mentioned the frequency of backup, which is done every night. In the second example, the author details 4 types of storage for the data on the researcher's computers, on external hard drives, on the cloud provided by the research organization. They state that the external drives are backed up daily. One last point, of interest for this example, the team organizes data validation meetings during which they harmonize file names and which results will be saved in new bake. For the part about legal and ethical requirements and a code of conduct, it's very important to clarify before the beginning of the project the legal framework and anticipates possible risk about the data. You need to verify if the exploitation of pre-existing data is possible, and to check if the reuse of the data is possible or if it's under conditions. In practice, be careful with these types of data: personal data, health data, data that raise ethical issues, data on which intellectual and commercial property rights apply, and data that are classified as defense secret. And if you collect data from websites, check the term of use if you are allowed to reuse it or not. One example about ethical and legal framework. So, sorry for the long text on the slide, but it's interesting because it's a team who is composed with the researchers for European Union and other countries outside European Union, and it has therefore done a preliminary work to define the international texts it will be rely on to manage the project data. So they list the texts who are relevant for their projects with a question about ethical and legal frameworks. For data sharing and long-term preservation, you have to make data easy to find and accessible, and ensure that data is reusable if you can open this data, if it's not health data or other types of data we will see. And you see data easy to find and accessible, and data and reusable data is the same as the FAIR principle. Ocean will be described to you later. So in practice for this part, you can use an open license, for example, the Creative Commons. You can identify and then use a trusted data repository. If you use a data repository, you can add a persistent identifier to your data sets, and then it's very important to share and to share other research products and not only the data, because if you don't have the code and software, the protocols, and these other research products, sometimes you can't read the data without these other types of results. Then for sharing an example, it's an example, it's interesting because it deals with data as well as codes and softwares. So you see the data the code is shared, on GitHub, which allows its reuse, and the data is shared here on Zenodo. All the data have a GUI, and the author has checked that the majority of the file can be opened with a browser and a text editor. So it's a very simple way to access to this data, to this shared data, and it's very interesting to see the author checked it before the sharing. So it's the data and code here are shown in this example in a very reuse-friendly way. So this is an example with a multidisciplinary repository, Zenodo. But if your institution use a repository and has already a repository, as for example, Unimi Dataverse, the repository of University of Milano, and the HeyData the repository of Heidelberg University, then you have to use your university repository. For another part of the GMP is about the data management responsibilities and resources. In this part, you will be define the roles of each person in data management and anticipate the costs of data management. In practice, it's for the roles, you have to appoint a data management stewards for the project and to appoint a person to write the data management plan. You need to estimate the cost of storage, sharing, and archiving your data. For the sharing, for example, you can have a repository with fees to pay, and to have a permanent archiving of data, you need to anticipate the cost. So we see the GMP in the different parts of the GMP. Your GMP is a living document. It's a deliverable that evolves. And you can you need to write a first version, which is expected 6 months after contracting, or 6 months after the beginning of your PhD, for example. A second version at mid-project or at mid-thesis, and then a last version at the end of the project. In Europe, we have two most used templates for the data management plan. We will take a quick look of the two most used models that existing to writing a GMP. Here, this is the Horizon Europe model, which follows the logic of FAIR principles. The question will check that the data is findable, accessible, interoperable, and reusable. This model includes questions about the data, the associated metadata, the chosen repositories, as well as the codes and software. And the other widely used model is the Science Europe model, which has been adopted by several national founders. It's a chronological model which follows the life cycle to the data. The question focuses on data management at each major stage of the project, from collection to archiving. It's a fairly simple model to use when writing your first data management. And I leave the floor now to Océane for the last part of the presentation.
So now you have seen some why use DMP. I will give you some tools to make your DMP. So first question to help you to find the right model. It's a summary of the requirement for European universities. You can first of all check on your university's policies to find the right DMP model. Then you have several tools to help you to choose a DMP in Europe. So you have the link and on the presentation, and some states have their own DMP finder tool. So don't so contact us in resume if you are lost with all this DMP. Contact your library or repository, university service. So we have the DMP, but what are we talking about? What to share? Research data, datasets, data records. There are many vocabularies to talk about. So the Organization for Economic Cooperation and Development define research data as factual records. So numerical scores, textual records, image and sound, used as primary sources for scientific research, and that are commonly accepted in the scientific community as necessary to validate research findings. A research data set constitutes a systematic partial representation of the subject being investigated. The OECD considers scientific information as two main categories: peer-reviewed scientific publication, so primarily research article published in academic journal, and in second, scientific research data, so the data underlying publication and or other data such as curated but unpublished data sets or raw data. Funders have some requirements. So in Europe, Horizon Europe demand a DMP and open data if possible. H20, I don't know how to pronounce it. If you are the pilot of the project, the open data have to be the data have to be open if possible. So, what data will be collected, processed, or generated? There is a slide about the example of research data type, because you can use some sources of data during the project. You have the primary sources. Before any processing or analysis, you have the data you collect on other researchers, so the external source data. The data you collected by questionnaire, survey, etc. After you have your result data. So the data produced after exploitation and processing of source data, and which constitutes the result data. And after all, you have the documentation of the data. So it's what Cécile was talking about. You have the metadata, you have the methodology you use, the materials, the data evaluation, etc., etc. In all of these data, what could be shareable, could be shared. It's a list. It's not exhaustive, but it gives you some concrete example. So you have the laboratory notebooks. It's really known, but you have also interview, expert reports, program of seminars, photo, etc., etc. The data may be numerical, descriptive, visual, or tactile. They may be raw, clean, or processed. It could be any format or media. So, for the data management plans, you have not to consider the preliminary analysis and draft. The program of future work, the peer reviews, etc., they are not concerned by DMP. With all this kind of data, type of data, you have some methodology and standards. So, as Cécile and Falco said, some open science practice are mandatory for all beneficiaries per the grant agreement. So the FAIR principle are the main standard you have to focus on. After you have data management guideline and good practice, You have some example for life science, social science, etc. It depends on the discipline. Some of them are very organized. Some disciplines have no rules, so it's depends of your sector. And for general information and metadata standards, you have two links which where you can find something by discipline. So if a metadata standard exists, you can find on this link. So these standards concern open access to scientific publication under the condition required by the current agreement. So responsible management of research data with the FAIR principles. So FAIR are findability, accessibility, interoperability, and reusability. It's notably through the general use of the DMP, but not only. It's good practice that older than just DMP. So the FAIR principle. It's the first step is to find data. So they have to be findable. Metadata and data should be as easy to find. Should be easy to find, and for both human and computers. So machine readable metadata are essential for automatic discovery. You have to have, for example, a unique and persistent identifier. The data have to be described, and they have to be registered or indexed in a searchable resources. They have to be accessible. So once a user finds the required data, they need to know how they can be accessed, and possibly including who they have to cite and if they have the authorization to reuse them. So you have to define if the protocol is open, free, and or no, to summarize. Donc, findable, accessible, interoperable. I'm sorry for the data usually need to be integrated with other data. In addition, the data need to interoperate with application or workflow for analysis, storage, and processing. If you have all your data in PDF, we can do much thing with. If it's a CSV, you can manipulate the data. So it's you have to define what you allow other researchers to do with your data, and so they have to be reusable. So it's good to share your data, but it's better if they're reusable. So metadata and data should be well described to be combined with different settings. You have a large bibliography about FAIR principle. It's just an overview, but so contact us if you want some precision how to do how to make data findable, accessible, or reusable. So here's the methodology, the standards, the principle, but the main sentence you have to focus is the data may be as open as possible, as close as necessary. You have not forced to share your data. In some time, access to and use of certain research data will necessarily be limited by various types of legal requirements. So you may have restriction because of the national security. So data pertaining to intelligence, military activities, or political decision making may be classified or therefore subject to restricted access. All the legacy about privacy and confidentiality, data in human subject and other personal data are subject to restricted access under national law and policies to protect confidentiality and privacy. However, anonymization and confidentiality procedures that ensure a satisfactory level of confidentiality should be considered to preserve as much as data utility for possible for other researchers. The trade secret and intellectual property rights, data on or from businesses on or other parties may contain confidential information that may not be accessible for new research. And after you have all the legal process, so data under consideration in legal action, so justice, may not be accessible. It's always possible to define rules of communicability, making the data open after a certain period, depending on national law. In example, in France, documents related to national security may be open after 50 years. The minimal standards in Europe are defined in the Transfer Convention. So you can have data which are closed during 10 years, but after 10 years, you can share them in open access. It will be open access as open as possible, as close as necessary. Mean there can be exception. It's recommendation that if you have some secret defense on your data, obviously you are not sharing them with all. So before sharing data, you have to check what it's your data. It's a summary. So green, it's open access. Orange, it's yes, but, and the yellow is yes, it could be, but under restriction. So people can get anxious about open by default when they equate by default with automatic. Open by default does not mean all data is released automatically. G should be only released after privacy impact assessment and processing to protect privacy. The main subjects are about personal data and health data. They are protected by the application of the General Data Protection Regulation. So the 5 main principal rules of the Gpdr are the principle of purpose. The person in charge of the file can only record and use information on natural person for a specific legal and legitimate purpose. The principle of proportionality, the information must be relevant and strictly necessary for the purpose of your research. The limited retention period, so it's not possible to keep information on individual for an indefinite period. In your DMP, you have to precise the retention period depending on the type of information recorded and the purpose of the file. And security and confidentiality. The person responsible of the data must guarantee the security and the confidentiality of the information. So they must ensure that only authorized persons have access to this information. And the person have access to their data. Personal data could be open after a certain period. You can you can share some anonymized data, but you have to be very precise. On your DMP, you have to precise all of the rules because you have to show that you know that data have to be protected. If you do what you want with your personal data, you will have problems with the Gpdr, and it may cost some fees. If you collect personal data, the person have access and can demand to delete their personal data. Be careful with personal data. You have to be very careful with intellectual and commercial property rights. If your data are concerned, if you haven't any right on, there are some retention rights. They could be open after 10, 20, 15 years. It depends on the contract you have. For Earth data, it depends if they are anonymized, and it depends on the confidentiality procedure. So you can share Earth data with another unit which has the agreement, but it could be not findable on all of the web. There are some tips to secure the collection of personal Earth data. It's a checklist again. So how long do you really need the data to achieve your objective? Do you have any legal obligation to keep the data for a certain period of retention? Do you have to keep certain data in order to protect yourself against possible legislation? And which ones? Maybe not all. What information must be achieved for how long? What are the rules for deleting data? What are the rules for sharing, and what are the rules for digital preservation? You have to document the conformity of the data acquisition method. The document formalizing the internal procedure, so the register in which the processing activities and the relative retention period must be recorded. The various actions undertaken, including whether these actions are still ongoing, not only the archive data, and the written instruction to the processor regarding time limits. The internal procedure could be any procedure for sharing, storing, archiving data, for destroying, and you have to describe security measures, including web paper records are stored, because the Gpdr include data which are on paper and on computer. It's the rules. Many of the problems related to access, dissemination, and sharing of data result from the lack of explicit institutional agreement on the term of access and use. Data management is becoming even more complex in certain areas of research, and traditional informal arrangement between researchers may not be longer adequate and may need to be complemented by formally agreed practice and procedure. The responsibility for the various aspects of the data access and management should be established in relevant documents. You have to formalize your procedure. And long-term sustainability of the infrastructure, I'm sorry. You have to know which institution have to store the data. So some tools, there are much links on this slide. I invite you to click on them after the presentation. So you have some tools to anonymize, to pseudonymize, to delete, to secure, and tools to name and rename by law en masse Be careful, because anonymization is often preferred to pseudonymization, because pseudonymization is a processing of personal data in such a way that data relating to a natural person can no longer be attributed without the need of additional information. But pseudonymization is reversible, unlike anonymization. So it's a tool which is pretty simple. It's simple to test with your own data, and you will be scared, I think. To review how to share despite access restriction. So anonymize, pseudonymize, share samples, and archive with access right retention. If the data if the use of data is restricted, it should not be for an indefinite period. It's better to have a specific agreement. The main sentence is have a specific agreement and document your acquisition method. Slide about license. The main license are the Creative Commons with several levels of use that can be articulated. You have also tools for Europe, which is Open License Assistant, and you can see if in your state it's this license which is fair or another. And you can choose what level of protection you want for the copy and publish, commercial use, etc., etc. Where to share your data? There are tools mainly used to share data related to publication. We are not talking about the data when you are making the research. So when you want to publish data related to your publication, there are some multidisciplinary repositories at Zenodo. You have some commercial repositories. You have to be careful with them, but we have to mention them because they are efficient. You have disciplinary repositories, Dryad, Nakala, etc. It depends of your use of the data and where you want to share them. And you have the organization repository, so the Heidelberg Open Research Data in the UNIME database, as Cecile mentioned before. We have a question before about in which cloud. It's not, these tools are not cloud, they are repository. So they are not for data which you want to manipulate. It's data which are validate or defined at the time, to be sure. So finally, the DMP as a feature tool for what? For improving, understanding, and using data, to define and classify your research data, to identify potential risk and challenges, and to align expectation with your supervisor and collaborators. It's very dense. We will take the question. First, Falco, you have a question at the beginning about the data leaks.
Yes, someone asked me to say something about data leaks. That is mostly related to information security, basically preventing unauthorized people to get access to your data. Maybe stealing the data, spying, that does happen from time to time. So if you have confidential or sensitive data, make sure they are stored in a secure location that you can control access to, and have all the security measures in place according to the policies of the university. There might be a requirement to actually log activities in case, something goes wrong, for example. So that could be an example for data leaks, unauthorized people getting access.
There was a question about what is versioning for Cecile, but some people began to respond.
Yes, there is in the chat the question and the answer. So versioning is you keep all the the different version of a file, and to do it you can keep it in a folder, but you can also use a version control system, and the most used is Git. You can use because it's very simple to use it and to manage then the different versions of the files.
We have a question about the cloud with security. I've begun to make a response. It's depends on the discipline. In my opinion, no clouds are secure, veritably secure with some security measurements. You have to contact your university because Google Drive, etc., are not secure. So in biology, I don't know some tools, but you have to contact your security information in the informatic responsible. I don't know.
Yes, if I can just it's very important your data are it's a cloud with data in Europe and not outside Europe. It's very important to be compliant with Gpdr. And then if you have an institute, a university cloud, it's better to use it if you can. But then if you need to have a cloud with a private company, you need to check it with your IT service and your DPO to check before the beginning of the project to check all the specifications for the security of the data.
About Nextcloud, it depends if you use your university Nextcloud or if it's a private Nextcloud. Nextcloud is a tool which can be installed on all the server you want. After, we have a question about of the data that can be anonymized. The recording of last speakers. The data can't be shared for now. So the recommendation is to archive them at your university archive or national archive. And they could be open to researchers, which in the Gpdr, we have an exception for this kind of data. So only public archive services are allowed to conserve this data. It's possible to archive them and make them accessible on the physical demand and the researcher have to define why they have to access the data. So it's a control access. I don't know if it's
if I may add, I think that's a really good example, Jana. Thank you for that, illustrating that there is research data that can absolutely not be made openly available because it might harm other people. And that's also an important aspect of the data management plan, actually, to identify those types of data and to some extent carry out a risk assessment, like what what can happen in the worst case scenario? What can we do to prevent that? What security measures do we need to have in place? And your case, it is covered by the slogan as open as possible, as closed as necessary, even if that means absolutely closed. So there's nothing that can be shared really. In Denmark, I don't know how it is in other countries, we have one possibility for that, which is called the National Archives. Other countries might have something similar. They are allowed to store those kinds of data. And if anyone ever would like to get access to that, they would have to go through a committee who then decides whether access can be granted.
I see Milan add in the chat the GitHub can be connected to Zenodo. Yes, it's a very simple way to, if you use GitHub to control your versions, your file version, you can use it because it's connected with Zenodo. It's very simple to share then all the version of the document of the data on. Of the project. Thank you. So it's about Horizon Europe. So you have to open the data, but if they are personal or individual data, you need to be conform with the Gpdr, and it's not if they are personal data, this data will not be shared. I don't know if Falco or Zen, you want to add something.
Yeah, it says open by default. So the expectation is to provide open access to research data, at least those underlying publications, and to justify if data cannot be made openly available. I'm just looking for a link I can share with you to some information material from Horizon Europe, which summarizes the requirements in detail.
So thank you for your attention.
All right, thank you very much, and enjoy writing a data management plan. Don't hesitate to contact your local support or us, and then we can forward you. Have a great day.
Goodbye.